Welcome to RGES Algebra 2, Lesson 18B, Part 2, and this is Section 5.4. So this is related to proportions. Now, proportions and ratios are similar to one another. Ratio is another way to look at a fraction, the relationship between two numbers, and a proportion is two ratios set equal to one another. Ratios, two ratios set equal. That's an S. All right. So, for instance, 2/3 equals 4/6. This is a ratio, and this is a ratio, and they're set equal to one another. Now, the cardinal rule, or the fundamental law of proportions, says this. In any proportion, the product of the extremes is equal to the product of the means. Now, there's two ways to write a proportion, so let's write a generalized one. A is to B as C is to D. Whoa, let me get this right. Sorry, I got distracted. As C is to D. These are the extremes because they're on the outside, and these are the means. So this is a proportion. One ratio equals another ratio, and the rule is that if we have a proportion, the extremes, that would be A times D, is going to be equal to B times C. Now that's one way of writing it, that horizontal way. Another way of writing it would be A is to B as C is to D, and in this case we'll see what we commonly refer to as cross multiplication. The top left and the bottom right are my extremes, so A times D equals B times C. And notice that these two would be equal, just as you would expect. So now, using that information, if I gave you a problem like 1/8 is to X, as, or 1/8 to X is equal to 1/2 to 4/5. That's a colon. Okay. Then what would I do to set that up? I would take my extremes, 1/8 times 4/5. My means equals 1/2 X. Solve for X. Oops. And I always love to, when I have fractions, I like to write it out first before I do any multiplying so I can cancel. This would be 1/8 times 4/5. To take that to the other side, you're multiplying by the reciprocal. Cancel. 2 times 4 go into 8, and my answer is 1/5. And so that's how you would do the first one. All of the others follow the same exact idea. Now let's look at some using these ideas for our word problems together. I find using ratios and proportions, especially proportions, just a wonderful tool for lots and lots of problem solving. So let's use the idea of proportions here. A car costs $22,000. Find the cost of a second car if the ratio of the second to the first was 3/2. Okay, so we want to find the car. We're going to have the cost on the left side. You could set this up several ways, as long as it's logical. And the proportion, or the ratio, on the right side. The ratio from the second to the first is 3:2. The cost of the first was $22,000. So what would be the cost of the second car? Okay, so you got to make sure that these things are properly related to one another, and these things are properly related. In other words, the second car is represented by everything on top, the first car by everything on the bottom. And so I'm just going to ask myself, this doesn't take, I could do this by cross multiply, but I could also just think about it. If 2 times what is 22,000, 2 times 11, so 3 times 11 would give me my answer. The new car would cost 33K. Let's look at another idea here. 9. The formula FD equals WD, capital D, expresses the physical law that when a lever just balances, the product of the numerical measures of the force and its distance from the fulcrum is equal to the product of the numerical measure of the weight and its distance from the fulcrum. Very useful physical law here. And so we've got, they want you to express this law by means of a proportion. Okay, let me draw this a little bit here so we can see what we're doing. We've got F and its distance, small d, and W and its distance, capital D. Okay, so how would I do that as a proportion? Well, this force, weight's also a force, right? The force is to the weight, which distance relates to the force. That would be the okay, and the question is, do I want the capital D or the small d up here? But I was given originally FD equals WD. So if I've got F on the left, my D here would be going down to the denominator. Okay, so I would have the capital D over the small d. So writing this equation, now here's another way I can think about it. Okay, is I'm thinking of the extremes and the means. I'm pausing for a second. Let me think about that. No, I don't like that explanation as well. Okay, I like my first explanation better. If I'm going to have this, I'm thinking I want to have my forces together and my distances together. Okay. And so if in the original equation over on the left side, if the force is in the numerator, then the little d will be in the denominator on the other side. And I think that's the best logical approach to that. Okay, number 10 on the next page. Ten says solve the proportion obtained in example 9 for W. So if I had F over W equals capital D over small d, and I want to solve for W, I'm going to put that in the numerator by taking it to the other side. I'm going to get F equals D over D times W, and then I'm going to take this to the other side, because I'm solving for W, by multiplying by the reciprocal. So F small d over capital D equals W. So make sure that's, we call it solving for a literal equation. Make sure that you know how to do that. For B, you're just going to plug in. 60 pounds is my force. Little d is 8, and capital D is 3, and go ahead and cancel. 60 times 8 divided by 3. 3 goes into 60 20 times, and W equals 20 times 8, or 160 pounds. Okay. And so I'd like to illustrate these because I like to show you how simple it is to use your cancellation technique. Number 11. The total receipts, the gross income of a coal mining company 1 year was 167 million plus. The expenses for the year were to the net income 13 to 12. Okay, expenses to the net is 13 to 12. And I'm 13 to 2. And I'm given the gross, which is 167 million plus. Okay? I'm just going to show you how this is done, okay? What were the expenses for that year and what were the net? Well, this is expenses to net, but I'm given gross and I want expenses. So if then I change this to expenses to gross, my gross is 167 million plus, I'm being very sloppy, not giving the exact amount there, then I need expenses over here in the reduced one, which is the 13, but my gross is not the 2. That would be my net. That means after you've had your gross and you take away all your expenses, what have you earned? Okay, that's the net. So down here, rather than putting a 2 on my bottom right ratio, I need to put 13 plus 2, because the expenses plus the net equals the gross. Okay, so let me make sure you understand that. In numbers or in amount, I've got expenses and gross on the left side, and in reduced form, I have expenses and gross on the right side. Now, I've got 3 of the values. I can solve for E by cross-multiplying, and then I could solve for N because I'd take the gross minus the expenses to give you the net. I didn't give you the answer, but I want you to go ahead and work that through and make sure you have a number when you come to class for number 11, a value, an actual value. Number 12, that's one of those mixture problems. So I want you to do 12 on your own, and I want you to do 13's a little tricky. Okay. Let me give you a hint on 13 and then see if you can do the rest on your own for 13. It says it's 14 over 24 pure. My first column will be the amount of the alloy, right, which is going to be the gold plus other, whatever else they're mixing with it. Then I'm going to get, I'm not going, let's see, it says how much more gold will be added, so I'm not going to add the other. So then I'll have the percent of the other. If you get these labels right, you'll understand these problems. And then you'll get the amount of the other, because it's the amount of the other that's not changing. Now, they say 14 karat gold is 14 out of 24 parts pure. That means there's 14 parts gold to 24 parts altogether. But I want percent of other, and percent of other or fraction of other will work. So rather than using 14 over 24, I'm going to use what's left, 10 over 24. And now I want to change it to 16 karat gold, or 16 out of 24 parts gold. That would leave me 8 out of 24 parts other. So using these values here, see if you can't do that problem. So again, you're in addition to 1 through 7, I want you to make sure that you also do, let's see, getting your answer for 11, 12, and 13 before you come to class. Okay, we'll see you soon.